grow. You grow when you have a desire to become better, to learn new things. When you listen to a webinar, a conference, a talk, go to courses, dozens of courses, then you are the one who speaks. You grow. You grow when you get up to speed. When you focus on your work, on your customer, on your team, then you become a part of something big. When you raise the bar and take responsibility for your work, whether good or bad. When they ask you for advice. When you create a small revolution or speed up an evolution, then you grow. You are growing because growing matters to you. You keep at it until it's just right. To be honest with yourself and others, to further educate yourself, to become an expert. And if it matters to you, it matters to us. APAM, focus on your growth.
Hi everyone. Welcome to the EPAM Autumn Data Conference 2024. We're delighted to see you. And this is the stream on engineering and excellence. Up next, we have an exciting session by Onan, an EPAM lead software engineer from Vietnam, with extensive experience in machine learning and big data analytics. Han will dive into efficient data processing for biological data sets, comparing the performance of Polar and DuckDB on the BELKA dataset. The talk will reveal how DuckDB outperforms Polar and speed and memory usage, offering practical, low-cost alternative to traditional big data tools like Apache Spark. Get ready to learn these solutions for managing large-scale biological data. Hana, here we go. Hey, how are you today? Can't hear you, Hanan. Please turn up the mic.
Good to see you all.
Good, good. How is the weather?
The weather is cool right now, and we have Thanksgiving and Black Friday today. Hopefully, we have all the audience that staring at this stage.
Yeah, I think everyone is really excited to hear about your experience. Just a reminder, please write the questions. We will have a QA session after Hanang's presentation, and the best question will receive a prize.
Okay, let me introduce again. My name is Hong. I'm living in Ho Chi Minh City in Vietnam. Today, we walk you through how we can tackle bioinformatics data with limited resources, especially on your laptop. We will use DuckDB and Polar as the tools to explore how we can manage effectively without needing a specific distributed system similar to Spark. The agenda today, I will share a little bit why I started these projects and why I work on DuckDB and Polars. Based on these two techniques, I will start to investigate what the difference between two framework and how it works on different data types. The metrics I will measure will be reported in speed and memory efficiency. And after that, I will share with you some latest trends in our big data community, how we can use these frameworks for machine learning integration, and what's the most company right now working on big data. And finally, question and answering session. Okay. Talking about NeuroIPS 2024, this is a challenge from the team, DEL. We will try to build machine learning models that can predict the binding affinity of the small molecules to a protein target. This is the problem of drug discovery, that if we train and can reuse the machine learning models, that will help the bioinformaticians find out new medicine that could help cure disease in the future. So this is the data set that we collected from this competition. As you may see, we have two data types, the CSV1 And the Parquet format, the CSV one, we will have train.csv, which is around 53 gigabytes, which is very huge compared with our normal working data set. Looking at the table schema, we can see that there are 3 building blocks. Building blocks 1, 2, and 3 written and represent as a smiles annotation. And also the target, which is the protein molecules that we try to predict whether or not these building blocks are binding with the protein, which means the drug or the medicine that could help attach to the protein to make some functionality effects. Okay, this is my first attempt. Cargo will support us a serverless notebook that we can read up the train data sets or test data sets for doing exploration or building machine learning models. At first, it support us 30 gigabytes of RAM. But when we use Pandas, which is our familiar framework to read up the Parquet files, it will curse the out of memory, which is we cannot work on this data set. Even very simple query like counting how many records, counting how many building blocks or molecule in our bioinformatics data set. So it will raise to our common solution that we will use Apache Spark to aggregate exploration on the big data. But as you may see, this solution may be overkill and very expensive to some people, just students, or we are just an explorer on working on these data sets. What if we want it quick? So when I look around, there are lots of frameworks that could help to achieve these goals. We have Polars, we have DuckDB, we have Aerodesk, or even GladeDB, Data Fusion. We heard a lot in our community of big data. But in this presentation, I will introduce and would like to use Polars and DuckDBs. As you can see on Star GitHub around these years, Polar and DuckDB is the most used and the most reference to. So I think these two frameworks actually contribute to the current projects, especially the big data projects that could help deliver the projects or making the application more efficient and optimized. So I would like to know what does it mean, and was it actually help us achieve this problem? Talking about ducks, yeah, as you can see, ducks here, they can swim, they can fly, they can walk on any other platform or any database and data warehouse, as you can see here. DuckDB is inspired by adaptability of the ducks and excels in resource-constrained environments. That's the idea, and why they call it is DuckDB. So this is a small sample query that DuckDB can directly reading up the Parquet files on AWS S3. Very easy and straightforward, that you don't have to define any other steps to use this. For Polar, this is also very high efficient that can leverage parallel execution or vectorization for significant performance gains. I think Polars and DuckDB will define of what we can do with limited resources. Okay, now the objective for our experiments, I will get the CSV and Parquet files from training data in CSV and Parquet. The objective is that we will compare the speed of aggregate and the time and the memory consumption of these two frameworks. In my machine, I use Windows 11 with 16 cores and 32 gigabytes of memory. We will test these operations like counting, filtering, sorting across both tools. Okay, this is the first experiment on counting. So on counting on CSV, as you can see at the diagram above, this is the number of iteration, 5 iteration, and we will measure the time of execution. At the blue line, it is indicate the Polar's time execution, and the orange will be DuckDB execution time over iteration to make sure that we will have an average execution time. So as you may see, DuckDB will have a efficient execution time, which is 10 or 15 seconds faster than Polar's. And below is the memory usage comparison. As you may see, it's also executed in different run iteration. This is 5 iterations. And in this diagram, you can see Polar consume a lot of memory. It's around 10 times bigger memory consumption than DuckDB. So in this test, DuckDB win in both time execution and the memory usage. How about Parquet? Was it more efficient in Polar? In this scenario, for time execution, DuckDB also win. It's around 2.5 times faster. But compared with memory consumption, we can see that DuckDB will consume stable memory, but in DuckDB, it will gradually increase over time, and also will achieve the similar memory consumption. And I think in this test, DuckDB will win in time execution, but in memory they are the same. How about more complex queries? In this test, I will try to aggregate, counting, filtering, and sorting much more complex than the counting scenarios above. In this scenario, we can see DuckDB again win the time execution, but compared with memory, it's also 10 times less than Polar in the memory consumption, because I think DuckDB can implement behind the scene to optimize reading and scanning the disk rather than load it up into memory in order to achieve the same calculation. Similarly to Polar, in Polar, in complex queries in Parquet, we can see that in this case, Polar's win for time execution, but lose in memory consumption. So in this scenario, we can see that somehow Polar make use of the resources more effective than DuckDB. I think in the future, if DuckDB can optimize their query behind the scene, I think they will have some breakthrough in time execution with complex queries for Parquet. Okay, this is reporting for reference, which we conduct on different runs, different file format using simple query versus complex query. And if you want to know on the real data set, I also give you the reference to the DB Wisdom, fast analytical processing for the web, which is also demonstrate that WB has good execution time for web application as well, not limited at the big data aggregate and calculation. Okay, so after all, we can see DuckDB is good choice for our solution. Based on that, I will share with you what else we can do and what are the trends right now in the big data community. Okay, the first thing is that all data scientists, data analysts, machine learning engineer, they will try to leverage SQL query to integrate to data warehouse or their application. Because as you can see now, the approach using ELT combined with DBT on data warehouse such as BigQuery, Redshift, Amazon Redshift, and Snowflake, they already integrate machine learning models into their query so that they can deliver machine learning projects quickly without more setup, end-to-end pipeline, very complex for only data analysis user or the quick prediction or forecasting projects. This is few link and source that we can leverage SQL query for machine learning. How about the extension for some machine learning algorithm? Is it possible? I have played around with k-means to demonstrate that we can do that. This is a reference for k-means that you try to cluster the items of the group into a group that we can organize the data, and we predict the data given the data set. I will go quickly just to demonstrate that we have the code. So for example, this is the random data set that scatter plot X and Y. First step, we will initialize our centroids, which is the coordinate of X and Y, which is we can create randomly during the first initialization. And then from this, we will calculate distance matrix. And from distance matrix, we will assign these data points into which initialized centroid previous. And we start to update the centroids with the new distance matrix that we prepare on the previous steps, and so on and so on. With first iteration, we have already cluster data set, and go through 100 iteration, we already achieve k-mean clustering by just using SQL query. I think in the future, if the community of DuckDB can contribute to the SQL query that can integrate machine learning, I think it's possible because Apache Spark did it very well. You can do graph computing, you can do logistic regression or anything based on SQL query only. I think this is a potential trends in the future. And this is the surprising truth that most data sets are not big data. The studies show that 90% of queries involve less than 1 terabyte of data, with most being under 100 gigabytes. So the tools like DuckDB and Polars will make sense for these workloads. In these scenarios, we will save a lot of costs and we will simplify our operation. We don't have to use Spark because I think most of data analysts will look back for 1 month and 2 months at max. They don't have to do the whole year aggregation data. But if they want, we already support it with sub query and sub aggregation report. So some controversial talking about big data is dead. I think this is the majority is that because the data we use today only a portion of big data, and the remaining data we usually we archive and we didn't touch it for a long time. So this is the reason why people are talking about big data is dead, but in some sense not accurately. Okay, in this scenario, DuckDB and Polars try to leverage single node architecture. So you don't have to prepare distributed system. As you can see at previous experiment, DuckDB only use very small amount of memory in order to aggregate and prepare the analytics reports for us. So you don't have to horizontal scale, you just vertical scale, upgrade your memory, upgrade your disk storage, and number of CPU, and it works. You don't have to set up a complex system. Okay, and trend number 3, I think the evolution of data lake or data lake house, we try to connect our user, our data consumer to our data platform. But in the market right now, if we set up a very complex data serving like API, like data warehouse with lots of complex query and setup. In this trend number 3, we try to minimize the gap between the data, diversity of the data in different data sources into our single query. So for example, we store our data in this S3 object storage, but in other case, we would like to retrieve some ad hoc data from the website like portfolio, the CSV. We can also do that with only our single query. And DuckDB supports us to do this. We don't have to set up a lot and prepare a lot of computing power in order to do that. This is an example that we can prepare multiple data sources and attach it, integrate it into a single query. And it also helps us to show the table schema, show the number of records, and very convenient because we already have a SQL query description to show to us what are the steps the DuckDB query SQL query execute, and if there are any bottleneck, we can analyze and optimize our query very effectively. So this is some current works of the community. DuckDB can work with HTML, HTTP client execution extension. We can use prompt engineering that integrate with LM with SQL query, and also we can build high performance data pipeline just using DuckDB. Okay, thank you for your time. This is my key takeaways that we can see that DuckDB is already suited for medium scale projects. In this case, we use BELKA dataset from NeuroIPS 2024 competition. And the second key takeaway is that most of companies don't have big data because most of data sets is under 100 gigabytes. If we work on small projects and not require very big resources or budget, we can think about DuckDB. It's very efficient. So another trend is that we can leverage single DB for retrieving multiple data sources. We don't have to set up distributed system at the first stage. And many features are going on, like machine learning integration, vector search, GPU acceleration for combining the data across systems. So I hope this presentation has inspired you to rethink of how we approach data processing with limited resources. I'm now happy to take your questions, if any.
Yeah, absolutely. This was really insightful, I must say. We have a couple of questions for our listeners. First one, I think, would be, so did you tailor somehow what you have been exploring and building, especially in terms of reprocessing the data, which would be tailored for some generative AI applications, right?
Okay, I think that's a good question, but could you repeat again what's the main question you would like to know?
Yeah, so I think the question is about if there is any specific big data reprocessing techniques which are tailored towards Gen AI applications, specifically Gen AI, or I mean, those suit every type of data application.
In terms of tools for Gen AI, I think right now we have maybe people are already prepared good data architecture that's ready for vector database, which is, I think, the foundation platform for Gen AI. And from this foundation platform, we can build any framework on top of that, such as DuckDB. I think in the future they will integrate LM models that can integrate directly into our vector database platform in order to respond which related documents should be returned. I think that's possible if we have very good foundation data platform and vector database with the evolution of the community. I think we will have supported in this case. Yeah.
Okay, got it. And what about implementation of retrieval augmented generation? There is a question in the chat about special requirements for retrieval augmented generation implementation, especially when dealing with large amounts of data.
I see. For RAG, as we may know, it will have to bypass the hallucination disadvantages of Gen AI. For database, we will come back to our fundamental, like how can we distribute store our data or vector data in our vector database. In this case, if the data not very huge, we can store it on single storage, but we can do it by distributed horizontally with our object storage on the cloud. And this is already supported by Milvus. And the second thing we could think of is how can we balance between accuracy and quickly retrieving. For accuracy, you can apply different algorithm index like HNSW that could help you quickly retrieve the document. But in balance, you need to careful pick up which resolution is good enough for the retrieval. I think that's the two main points that we could consider for applying RAG.
Okay, doke. So I think we have some more engineers joining the stream because we're diving more in technical details. So the question from Alex Fedorenko here. Do you have a chance to compare memory consumption with lazy versus eager API in Polars?
Memory consumption with lazy and eager API in Polars. To be honest, I didn't have a chance to experiment that features. Yeah, I use the common read and calculate and aggregate for both DuckDB and Polars. Yeah, I think that's a good experiment. I would do it in the future, but right now I don't.
Okay. For sure, I think you will have an opportunity, right? Andriy Royka asks, so such structures as smiles seem to be very repetitive. Have you tried to play with compression techniques to get the storage cost savings? Feels like a reasonable sorting could apply powerful RLE. Not sure what RLE is, but probably, you know what it means.
Yeah, I think smiles is the data format that statisticians very familiar with. But if there are any data format that could compress the data, I think we can, because smiles are basically just a text. So if we could use like some packet format or Avro format, we can also do that, the compress techniques. I don't know RLE means. Yeah, if you want to compress the smiles, I think we could.
Okie doke. Roger that. I hope, Andrew, you got it. Another one from Andrew. Do you think there is any real performance difference depending on which compile language the data processing tool was reading on? Rust versus C++, etc.
Okay, I think so. Compared with Rust versus C++, if theoretically C++ will outperform Rust, I think, because Rust is another layer upon C++, but combined in different techniques, in different way for our developers effectively use that for our implementation. So I think in theoretically C++ will outperform Rust and the other language, but I think in some scenario problems such as GPU optimization, for example, or building application, I think not mention the physical and time of processing, and we should consider other aspects like time of development and time of deliver the product. So yeah, it's quite hard to decide which language is better than the other.
Okay, thanks for sharing. And I think we have the last one on our stream. So Alexander Sherbak, joining us live, is asking, what is the difference between DuckDB and any query engine like Trino? Is DuckDB something like a query engine?
Yeah, DuckDB, as that definition, it is in-memory processing database. So we can think is pandas, but working like SQLite. Yeah, it will help developers to connect the data source and working on programming only, compared with Trino or Athena, which is already built up the user interface or prepare other library connection GDBC that could help us connect to different data. But I think DuckDB is more flexible because we're working on programming environment so that we can working on unstructured data sets or any kind of complex machine learning algorithm compared with Trino.
Okay, really interesting. Okay, I think that's all the questions we have as of now. So which question did you like most? Who will be the winner of the subscription for LinkedIn?
Okay, let's review a bit.
Yeah, so it's API, lazy versus eager, smile structures, languages, and preprocessing difference, right, and performance, and DuckDB difference from other databases.
Okay.
We also
if you
had to
one
first about pure augmented generation and tailoring it to GenAI applications. That's right.
Yeah. I think I would choose Andrew Rocco for the performance comparison between compiled language and such as Rust versus C++. I think that's a good question because we need to experiment and consider different aspects, not the machine itself, but also the language that build up on that.
Congratulations, Andrew. So please get in touch with EPAM team. I hope you know the context. I think they should be in the description of the stream, of the main stream and the stream, or if you know, unaware, just find someone at LinkedIn and will help you find me in LinkedIn and Ankh, and we will, make that you will receive your prize for the best question. Okay, so thank Han for an insightful presentation. That was really interesting, very technical. We got deep into details, so I hope we learned something new. Thank you, Han.
Thank you. Have a great day.
Thank you for joining us for this session. Up next, we will have Vasyl Lyashkevych with his talk, How to Scale Business with AI. Vasyl will dive into how AI and generative AI can tackle common business challenges and drive scalable growth, both vertically and horizontally. Stay tuned for practical insights from a seasoned experts with over 15 years of experience in research and development and enterprise innovations. You won't want to miss it. So, in 20 minutes, join us with Vasyl Lyashkevych. I'm with us.
Yes, thank you, Ivan. Thank you for so pleasure.
Yeah, welcome back. I think I've talked to you last time around a month ago or 2 months ago. How it's going with you and EPAM? Are you all right?
Yes, I'm completely satisfied, and I like that I'm in that right place where I can grow. In the same time, I can grow with our clients.
Yeah, absolutely. I mean, when I heard about your experience, especially like a competency, because you're really PhD, right, in computer science, so you know a lot and very deep, and also on a theoretical and practical level, I was really impressed. So I'm really looking forward to your presentation. Really looking forward to. Just a reminder, so our listeners will post the questions in the YouTube chat, right? And then we will select the best question and we'll give out one LinkedIn Premium subscription for a year. So Vasyl, you will be choosing the winner, right? So we'll hope we get interesting questions for that. So, okay, no longer spending anyone's time. Let's go with Vasyl's presentation.
So, thank you for introduction. First of all, I would like to thank you, all of you who are going to listen me. Actually, yes, I have experience from in both in academical and industry background, and I try to combine together benefits from one to another because it is interesting to see how new opportunity appears in the stitch between academical and business domains. So let's start. Today, I will try to focus on a couple questions. First of all, it would be fine to understand what is going on with scaling and growing, what the difference here. Also, I would like to highlight the power of data because data is actually our oil today. It's oil for our modern digital business. And of course, capacity of AI, how AI can bring the new value from already existed one and how to leverage by different levels of values, etc. Also, we will talk a bit about authorical resources about business scaling trends 2024, and I will try to show one of the possible frameworks, actually how to do this, how to scale business, how to listen to the client, and how to fit with client requirements. I hope it will be interesting for you. I include a bit textual information if you want to listen or want to work with presentation after. So let's start from the definitions. When we talk about business growing, business scaling, some years ago, I cannot understand what what is going on. I saw that I think that it was similar terminology, but with different aspects. But let's clarify. Actually, when we talk about business scaling, we understand the revenue generating capability by leveraging the existing resources. We try to use resources, existing resources, more efficiently. And as example, you can see a SaaS company can invest in cloud-based infrastructure to bring up more clients, but didn't hire any staff or with minimum hiring. When we talk about business growing, in this case, we can understand the volume, we can understand the scale. It means geographical scale. We can talk about expansion of new markets, expansion of new products and new streams, etc. In this case, efficiency is not a prior goal. So let's do next. And what the difference, key difference between scaling and growing to split out them. When we talk about on the cost and revenue aspect, we can see that revenue increases significantly faster when we do scale. When we do growing, it in the proportional rate with investment. When we talk about efficiency, so scaling is efficiency is the focus, main focus, and growing the main focus is expansion. When we talk about sustainability, so for scaling it is a long-term problem. For growing it is how to say a business plan. And objectives, building the scalable and efficient model for scaling, and for growing it's expansion, it's volume, it's new something bigger. And a simple example of this key difference says here, deploying automation then faster customer demand. So when we want to increase or when we want to process 10 customer, we will automate. We will see how to use the same resources to process the 10 customers. When we grow, we didn't care about that. We just add new employees, etc. When we scaling, we should understand the scaling is still process which could be applied for different directions. For example, let's clarify that we talk about AI power, we talk about data. So we are oriented to scale the business with software applications, etc. And in this meaning, horizontal scaling considered, and we increase the application capacity. We can increase the existing infrastructure, so we can add new instances, new machines, new nets, etc. But when we do vertical scaling, as you know, we will increase the capacity of that node, capacity of that system, etc. And you can see some key factors comparing one another directions. For example, when you have costs or budget, we scaling horizontally, it is higher initial costs. Vertically, it is more cost effective initially. But in any way, you keep paying attention that we as minimum should do any investigation, any investments on these scalings. For example, when we talk about application architecture, as already talked, we during horizontal scaling, we look at the direction where we can distribute the system, where we can reuse already existed patterns, etc. For vertical, it is capacity power, because vertical scaling would during short term increase the revenue stream. Also, you can see we have still different aspects, and some of them we will talk later. Uh, Now we have a choice how to scale, what we can propose our client to scale horizontally or to scale vertically. And in both directions, we have some different motivations, ideas, goals, etc. For example, when we want to choose horizontal scaling, so in this case, we will simultaneously add new nodes. We can increase infrastructure. And for example, it's so easy to understand when we have local machine, we can add still another local machine using load balancing, etc. And we can use microservice architecture first because it's so easy to implement and distributed system, and it is cloud native architecture. And it seems like this direction is so understandable for us because we start with uh, it's modern patterns for software development, and a lot of these approaches we can propose to the client. But when we choose vertical scaling, we still have a lot of benefits on a par with horizontal. For example, sometimes our clients has mm, uh, um, so how to say legacy solutions where we cannot split by microservices, and in this case it's so difficult to grow horizontally. In this case we should pick up another way, scale vertically this business. It means we will increase the server's capacity, will increase the memory volume, etc. network. And legacy system is the best application, the best example which fit for vertical scaling because we increase the capacity of the systems without any changes in the code. When we talk about short-term scalability needs, in this case, vertical scaling could help significantly because we just increase capacity and we have new revenue. In horizontally, we still need to do any operations, and we still need to prepare for that. And cloud sustainability, of course, as already mentioned, was it is one of the way where we can choose between vertical and horizontal cloud. So, and finally, investigate these directions, which could be useful for our clients, for each client independently. And we found that there are some similarities between horizontal and vertical scaling. It means when we increase horizontal scaling, we in the same times have benefits in the vertical scaling. So that's thanks by already new business values. It means for example, in the past, we work with simple analysis without artificial intelligence. After we switch to new artificial artificial intelligence rule-based system, after we switch to the ML and deep learning, and now we're working with generative AI, and of course we uh, grow the latest years with data. We grow with business values because we talked about some data attributes 20 or 30 years ago. 15 years ago, we talked about another data attributes, maybe some business values, which can cover it by data attributes. And now we can talk about new data attributes because generative AI brings our new environment, a new space for working in the business, for new space for data. It meaning space thanks by embedding techniques. So, and in this case, some values which help us grow horizontally and vertically in the same time can do for us. You can see and after it more. But finally, when we analyze all the similar uh, mm, use cases for vertical and horizontal directions, we came to the main interesting hybrid scaling approach for caterpillars. For example, let's focus on the flexibility. Uh, as horizontal as vertical scaling approaches going to support and have a right infrastructure at needed time. So, and be easy to any changes because we have a lot of changes on the market even every day. After cost effectiveness, sometimes when we scale a bit vertically, we enable something for horizontal scale. When we increase horizontal scale, we enable vertical scale. And in this case, we can talk about optimization. Sometimes we can choose what the better to have two cheap instances or one more powerful. And next, we talk about performance. Performance, it's ideal for both directions, and performance could be achieved by different approaches. But in any way, when we increase performance for vertical scaling, at the same time, it will be useful for horizontal because it could enable something for horizontal scaling. And scalability, of course, it is that's we are talking about. We talk about approaches which can break our limitations, business limitations, and propose something new. What having these approaches on the strategic level, we can understand it is scaled to good, but how to scale and for what scale, what we will scale. We will scale infrastructure, we will scale capacity, what we will scale product. And here you can see some business models, how to work with scaling and how to prepare ourselves for scaling and what the business targets here. First of all, you can see we can talk about economies. So we can scale business by making some products more cheaper, making the conveyors more cheaper and more effective, etc. In this case, we can grow with revenue, and it will be our scaling model. When we talk about technology, in this case, we can see how to map our legacy system to the new, how to fit new innovations, etc. For example, how to use computer vision and robotics, etc. Also, it could be automation because some of clients, for example, didn't have yet automated production pipeline or another things for automation. So in this case, we can talk about automation too. And the same for business structure, for digitalization. And for digitalization, it is a pretty cool story because decades ago, maybe 2-3 decades ago, we started to think about digitalization. We talk about we live in the digital world, informational world, etc. But what is next? Next, maybe virtual world. When we talk today about digital products and services, tomorrow we will talk about virtual product and services, etc. And of course, standardization, because standardization allows to manipulate, allows to assess better different nodes, what we have, different things in our production pipeline. And of course, when we talk about standardization, we fit still some another requirements regarding to productionalizing, digitalizing, automation, and technology. And of course, economies. It's a very powerful approach. And the same, we talk about production. We can increase this production. We can, mm, for example, do business on the one or two scalings directions, more powerful based on different feedbacks from the client, from the customers. We can represent the business in new way, represent business thanks by data, etc. And of course, customer interactions, as you know, it is the first one which we should talk today. But in any way, before we talk about scaling, before we propose our client the scaling opportunity or growing opportunity, we should understand if the client fits the scalable conditions. So in this case, there are different interesting use cases. For example, the client should be sure he have the appropriate rate or brand on the his products, services, a brand on the local market, and the client has a stable income during couple months, maybe a couple years. The client has stable investments and have appropriate budget for scaling opportunity. And also clients should assess if he actually ready for this opportunity to with much bigger business. And of course should predict what is going on the market with after he is growing, after he's scaling, and will assess, maybe do some analysis or prediction how it is going on after. And of course should understand and see perspectives that as minimum some percent is like for different businesses is different criteria, will have appropriate incomes in the future. So clients should be ready. And now let's go to the next topic, a bit about data. About data, we heard a lot from different resources. That I won't stay a lot on this stage. But what I can say, or let me recap. Data could be different. It could be tabular data, it could be structured data, unstructured, it could be images, charts, etc., textual data. It is one of the way to understand something. What we are going to do, all our analysis is going in our brain based on words. So when we see look at the table data, we can explain this not digits. We explain how we understand that status, business status. We can explain by words. In mathematics before, we built graphs, we built predictions, data plots, etc. But thanks by generative AI, we can describe each type of data. We can easy map data. We can easily work with data, process data in the meaning space. We will return back to this later. And today, DataNum can help with this in decision-making process because when we have appropriate data, we can easy came to the valid decision. We can exclude a lot of risks. We can understand the measure. We can measure ourselves. We can understand where we are and what is our power. Also, personalization is still an enabled opportunity at the moment because we have a lot of data from the customers. Latest 10, maybe more years, a lot of data were accumulated as different feedbacks, have different description, different comments through a lot of different services, social networks, etc. And we can understand different types of people. We can understand different types of our customers, etc. And we, of course, we can more accurately propose something. And optimization is still good thanks by data, because when we have data, we can see the different deviations from the ideal cases which we want to have. We can see where we can reduce something, reduce cost, for example. We can measure different productivities, etc. And in this case, we without data, we cannot understand what is going on. And the predictive capabilities, of course, the right data, it is powerful tool or powerful source which we can use in the predictions, because we have historical real data. We can trust that data, and based on that data we can do very strong, powerful time series predictions, etc. I will not comment all of these items. You will look at them later. Still, I would to focus on the innovation. Innovation is a pretty interesting area because innovation it's sometimes anybody associate innovations with cut-off-face technologies. Yeah, it's like 20 years ago we talked about computer vision, we talked about time series predictions, we talked about neural networks 10 years ago. No, so but even that technologies were appeared 80 years ago. The same generative AI was appeared still 1950. So, but it was not famous. It was not applicable. But at the moment, data allows us talk about innovations. Innovations, it means we can bring variety. We can resolve some problems in innovative way as didn't was before. And data enable this innovation stream, and this innovation stream can lead to the more efficient solutions in the future. And you can see, I try to understand how artificial intelligence can recognize the data, what the data is actually. And I try to build the image for you to show what the data is and how to enable data. What does mean enable data? Yes, we have a lot of data, and sometimes we even don't know what we can do with the data, how we should represent the data, what the right formats of the data, how many chains do we need to have in the ETL pipelines, how to accumulate the data, how to store without any losses, etc. And actually, I found that artificial intelligence is the right enabler for the data. And artificial intelligence allow data to express itself, allow to see the power of data, to recognize different complex patterns inside data, what we have. And that's, I imagine, AI, like, as you can see, hidden electrostation, where data is water. Also, another look, or I try to consider the data from business side and understand how I can propose data, or what I can say the business about data, how they can work with data, what data can help them. And here, simple example, how to prepare, how to make a dessert from the data. First of all, we need to collect the data and aggregate. We should align data based on different time marks from different resources, different formats, etc. We accumulated a lot of data. It could be like ingredients for our dessert. After, we will clean the data and process the data, yes, as we do with apples and orange and, and other fruits or vegetables. Yes, what we do, we just clean them before we use. When we clean, now we can analyze the data. We can understand what actually the quality of that data. When you prepare something or when you cook, you see it is okay, smells good or not, etc. Color is good or not, consistency good or not. In this case, we do the same with data. We do data analysis. We explore the data and we look at the data, if it's good data or it's not, it's enough we have data or not, etc. And I think it is pretty interesting place here, because do data analysis and make a decision what we should do with data, actually, it is pretty hard question to answer, really. Because as usual, data engineers just try to extract more stable route from data source with changes, with sometimes we exclude anomalies. Yes, we exclude anomaly detections, and we trust and we the normal distribution. Yeah. But maybe sometimes anomaly detections, we should use anomalies to describe different peaks on the boundaries between data clusters, etc. And so on. It's still a tricky question. And next stage is building predictive models. When we do predictive models, it's like in the cooking or making the dessert, we just prepare something reasonable. We prepare the model which allow to make a decision. And when we do dessert, we just make a preparation. We try to merge together all ingredients and look at the dessert. And finally, we can make a decision we can implement the decision and monitor. The data actually is used for this during these 5 steps. It's a common steps. They are required. It's we cannot avoid them, but we can do on each stage less, more. It depends on already what we are going to extract from data. And here you can see some strategy because when we talk about scaling, we still should understand scaling from data vision, from data side or artificial intelligence side. So we should understand, or we scale data through the company, or we scale data through the solution, through the artificial intelligence, or we scale artificial intelligence through our solutions, through the data, and in this way we help to scale our business, etc. But in any way, everybody should pay attention for data strategy, because data is accumulating and every time, and when we process data, every time we have losses, and that losses sometimes we cannot recover. We need do accumulation again and again, and in this case planning on the data level is pretty required, and here you can see a flexible data architecture. Also, you can see data governance and quality. I would like to say that is a required attribute, because when we do predictions and we should assess that data, if data is assumingly 80% of quality, and what will be our prediction model. But that 80% of quality we should measure. Still, there are a lot of quality metrics, how to measure the data. And regarding the data security and compliance, we still pay attention for that, because data can help a lot and we should pay attention. Uh, Regarding the tools and technologies, every time we have new and new tools, we have new technology, and I hope we will have a lot still technologies and tools in the future, because at the moment we on the technology level which allowed us reuse a lot of patterns, reuse a lot of code, etc. A lot of parts are already done. And of course, scalable analytics and reporting, it is very important, because right reports can enable us with a right decision, can enable us a smart solution, because we will be confident that we have the right information. So, and regarding strategies for scalability, we can highlight some of them. And first of all, I would like to say that data should be alive. So data, we can process data, we can store data, and we can scale the data. The scale data, it means when we have new data, and when we want to do scaling, we should be confident that we know where and how we will store the new data. When we, for example, we create new shop, and in that shop we will have application. That application will have our database. What's the database schema? How to integrate that schema in our already existing schema, etc. So we always still should pay attention to the data architecture. And now let's go a bit about AI capacity. I will try to be short here, because it is already known, a lot of known patterns here you can find, and capabilities. As usual, artificial intelligence can do some improvements, or can allow them do some things. First of all, recognize the patterns. Also can help us automate. Is first of all. Also can allow us in set up associations between different patterns, between different objects, and find out uh, the semantics or relationships in the patterns, which are not allowed for human. That's the moment we already prove human performance level is beaten by neural networks. But in any way, for business, artificial intelligence allow achieve some intentions. For example, you can see enhance customers' experience, improve operational efficiency, automate decision-making process, and etc. So it seems like we have top of 10 business intentions, but these business intentions is when we implement by artificial intelligence allow a lot to do and a lot to grow in scale. For if we talk about vertical scaling, so artificial intelligence can allow us do something interesting things. For example, predictive analytics, process automation, and NLP. I would like to comment NLP because sometimes I can understand, no, I hear different interpretations. Somebody thinks NLP is a part of artificial intelligence. Somebody thinks it is a part in another domain. What I would like to say? I would like to say that NLP is a part stream, it's a part domain which process natural language. And there are a lot of simple algorithms, simple techniques in this domain. Artificial intelligence is here is as one of the methods or one of the algorithms, how to say, where could be applied. From artificial intelligence perspective, it's place for application. It's where we can apply artificial intelligence. But NLP is not a part of artificial intelligence. And it's my opinion, because there are different opinions we have around the world. So, and also let's pay attention for the supply chain optimization. It is pretty hard to counting on possible risks for working with supply chain optimization, and with supply chain it's and optimization problem, it's so difficult to resolve manually. So artificial intelligence can help here. Why I highlighted artificial intelligence but not generative AI? Because it is common way when sometimes we need to use artificial intelligence. Sometimes we need to use single regression model or single classification model. We don't need every time use LLM or GANs network, etc. So at the horizontal scaling, we have, as you can see, custom segmentation sector. It's pretty good to understand when we want to work with customer. We should understand that we in horizontal scaling, and it means we when we our client want to scale or want to have POC or want to increase customer segment is. So in this case, we should understand what we should propose them. So we should understand that is horizontal scaling. Customers don't want to increase the volume of system, etc. And don't want to increase the budget or something like that. But with the customer segmentation, we will pay attention for factors or features of horizontal scaling. And also the same we can understand for another directions. Now I will pay attention about three things. It's just a quick example of what generative AI can help us. And first of all, we can talk about software development lifecycle. Or you can see example here. Generative AI can help on the each stages which we have. The same generative AI can help with platform migration. You can see in each stage generative AI can help us. And for product design too, generative AI can help us. The same you can do for client. You can analyze the client pipeline, you can analyze the client solution, and you can amplify that solution with different approaches. So here you can see authoritative insights. A lot of companies around the world which pay attention to the business talk about the same, as you can see here. And from that, from that outcomes, I can understand that when a client want to scale this business, we can measure. We should measure, and we have some expectations. You can see here. And finally, you can see I just won't comment. It's put for you. You can read more after when business can be scaled, when business is ready for scaling, and you will see this like a tutorial. So I would like to show you one example in telecommunication. For example, when we talk about communication, we have from horizontal scaling, we can highlight a couple directions. For example, market expansion, localization, product and service. No, market expansion, extension should be, not expansion. Expansion is horizontal. Vertical, sorry, product and services diversification, and has a customer experience across channel. So these seven, I highlighted seven potential region of interest. So it's just to show you how this framework works. And now you can see the same I did for vertical scaling. I highlighted 6 of them: product development, innovation, customer services, experience, operations, etc. And again, we have research and development too. And what I can expect from this. For example, for example, when I analyze together these vertical and horizontal directions. So I understand that some of them, how to say, have some similarities, or maybe not only similar, but can cover one another with different dependencies. Here you can see high and low. Low, it means no, there are no dependencies, and high is big dependencies. And how to define if I'm right or not? I go a step more, and I highlighted for each direction still to some sub-directions for horizontal scaling and for vertical scaling. After I prepare a pretty big table and I go through the table. So in real, it should be done by different experts. So different experts should go by these use cases and define them. But here we have only, I was alone, but in real, it should be some experts. And I defined the correlations between different streams here and highlighted the most powerful of them. And actually, I found the region of interest for hybrid scaling here. Based on that, I defined for each of these predefined area, I defined some use cases on intersection. You can see what here is example for vertical criteria 5, research and development, and horizontal. And the same I did for vertical criteria and horizontal. After that, I need assess that deal. And I predefined business attributes and technological attributes. It is not all of them. It's just to show you how it's going on. And here you can see I range this, and another experts should range all of these use cases, and based on real data, what we have here. So using the power of real data, we can significantly increase the expert vision here and predefine what the top, how to say, top use cases for other clients. Here is final results when we scale through all industries. You can see a lot of different industries here. So, and for each industry, if different use cases will have different impacts and value. So it seems like still we have pay attention to the blockers when we do this how to say analysis, because there are some dependencies in the technologies which one technology enable another one. That's it what I would like to tell you today, and maybe you have some questions.
Yeah, absolutely. Thank you for a very thorough analysis, I would say. There's a lot of content. I hope everyone had a chance to comprehend. So I think we start maybe with the first general question for me. So look, Vasyl, any other business is very different, right? So you have like various industries in terms of, domains, you have different client requirements, internal frameworks, etc., etc., etc. So while having such a, concrete framework and concrete classification, what is the flexibility of that? How do you align with these differences? How do you adapt?
Good question. It's actually uh, uh, when we have no, I would like to say that before we go with this approach, we should understand what a client is and where is our client, and what our client needs. And for example, if you can see here, we have this opportunity for the client, but
Can you share the
before
slide, please?
we
Because
have
we don't see the slide, actually. Cool, thanks.
yes, we have business. Yes, we have scale conditions. So, and when client ready with some of conditions, we can trust that. Of course, it is good idea when client can share some reports. We can investigate uh, his data, and based on that, we can understand what we can propose to the client. So, because it is very important to know where client is.
Okay. Got it. Because, like business adaptation is the key. Yeah, and I think also success also is dependent when we have a very solid business consulting expertise, right? When we know the business of our customers very well, not only from technology perspective, but from the domain point of view. Okay, back to some questions we have in the chat. So the question from Andrew Rutz. What are the typical low latency project domains where you had to apply AI? Maybe like low frequency trading, etc. So I think this question, are we talking about some, established, low frequency business processes and data, but some, this is my understanding of the question, but you see it on the screen, right?
Yes, I see, and I try to understand how is going on latency project domains.
I think maybe this is related to implementation, right? Maybe, or
Yes, it's more technical. It's actually technical aspects, but how to resolve this? It's first of all we should have monitoring tools. We should gather the statistics. We should inspect the in which cases which latency is, what the data in that moment was involved with, etc. And maybe we should analyze in the chain each each operations. When we talk about latency, it means we do something with and we spend time for some operations. In this case, we can do decomposition, the task. We can apply another algorithms to resolve the problem. We can no, it's difficult to answer adequately without more context.
Yeah, I agree. Another one from Andre. It's hard to believe AI can truly solve real business problems. It's expensive, needs super skilled people to make it work. In your experience, what's the most budget-friendly AI solution that still delivers results for a business fast? So what is like really could be used, as a fast deployment and, business enabler in the current
Yes,
landscape?
yes, it's. I think it is one of the most uh, how to say top questions
Frequent questions,
because
yes.
actually AI didn't resolve the business. How to say didn't uh, resolve all the business problems. AI helped us intellectualize some operations in the chain of our decision-making schema. For example, when we do business, when we try to make to come to decision, we have chain of thoughts, or maybe we have chain of operations, and AI can help us on these operations. At the moment, we still cannot trust 100% to the AI that AI resolve business problems because at the moment, still AI depends on the data, and AI is still on the stage where it's like can resolve some problems based on data, but to resolve business problems, AI should be so far. Uh, because at the moment we generate new business values, and it is next stage from the data. To make a solution, it's still next stage. I hope at the moment there are a lot of companies work about this problem.
Okay. And I think the last one, because we have just 2 minutes left, so let's try to keep it short. Larissa Matolinets is asking, what field of AI algorithms are the worst latency-wise? How do you leverage this from your experience? What are the techniques? Field of AI algorithms worst latency-wise. Do you have an idea what this question is about? Probably computer vision, right?
Oh,
So
sorry,
yes,
yeah, something happened.
Probably computer vision, right? Because more data you have, more latency you have, right?
Yes, I think yes, it could be like computer vision problem, because actually AI algorithms, no, deep learning is we still should understand it's a system of nonlinear equations, and we should calculate. We should calculate matrix by matrix, matrix by vectors, vectors by matrix, and thousands times. We cannot speed up this process. We can do some parallel, etc., but here we should leverage. Yes, if there are implementations where we can scale this calculation graph, but it will be more cheaper, and it was impact on the business, and business won't take that solution. Benefits, we should leverage between benefits and technical opportunity.
Okay, so Vasyl, who is the winner of LinkedIn Premium subscription? What question you like most?
No, I would like to say is that second question from the previous.
And Dream Ruts, right?
Yes, it was. I think that
you
more.
liked it. Okay.
Yeah.
Henry, congrats on winning LinkedIn Premium subscription. Please contact our administrators. You have their email posted in the YouTube chat. Congrats. Vasyl, thank you very much for a very thorough and insightful discussion about business strategy and technology strategy for businesses, the contemporary AI-driven world. Up next, we will have Orest Chukla, who will explore metadata-driven data ingestion frameworks and how they can transform data handling and enable smarter decision-making processes. Stay tuned for valuable insights from a very experienced big data engineer. Hey everyone, welcome and welcome back to our Data Atom Conference 2024 from EPAM Systems. This is a stream engineering expertise unleashed where we can dive very deep into various technical discussions in relation to data, big data, AI, ML, and all, cutting-edge technology we have currently on the technological landscape. So, up next, on Data Conference 2024, we have our new guest, Orest Chukla. He is a senior software engineer from Lviv, Ukraine, who will be speaking on the topic about how to build a scalable and efficient metadata-driven data ingestion framework. With deep expertise in big data tools like Databricks, Apache Spark, Azure, Orest will walk us through the architecture and best practices of metadata-driven ingestion frameworks and how these solutions can be game changers in simplifying data handling, empowering data-centric decision-making for modern businesses. Orest, how are you today?
Thank you. Hello, everyone. I am good.
Okay, so are you ready to, tell us more about these very interesting ingestion frameworks?
Yes, actually, I can start presenting it.
Yeah, sure. Absolutely. Everyone, please don't forget to post your questions on the YouTube chat because we will ask them to Orest in our Q&A session fragment. And then Orest will pick up the best question, who will win or she will win the YouTube Premium subscription for yeah. So Orest, please, we can start.
Okay, thank you. So actually, my name is Orest Chukla, and I am senior data engineer. And today we will talk with you on a very important topic and very interesting topic that is the center of any data-driven enterprise. And our discussion today will focus on building a scalable and efficient metadata-driven data ingestion framework. So today we will take a look on what is this data ingestion process, why it's critical in data engineering expertise. We will introduce you to metadata-driven approaches. And after it, we will take a look onto architectural overview of the design at div. Also, I will show for you benefits of architecture at div, and we will make with you conclusions. Okay, but before we dive into our solution, let's discuss first the problem that led us to develop this data ingestion framework. This includes a lot of factors, actually. It's like economical issues, technological issues, resource management, flexibility, and so on. So let's go through them one by one. So on the slide, you can see described some of the problems, the identified problems in data ingestion process. So one of the biggest problem is resources, the usage of resources, because if we don't use our resources smart, it can lead to decreased performance, it can slower processing speeds, and also it can lead to resource wastage. Another issue is related to finances. If we don't handle our data properly, it can lead to mistakes, and fixing these mistakes can lead to wasting a lot of money. It's also essential to talk about flexibility, because if our systems are too rigid, it's really very hard to adapt it to new changes, to new data formats, to new business requirements, and so on. Also sustainability. If we use too many resources, it's also not very environmentally friendly. So we have to consider this as the impact of our work on the world around us. Also, we don't need to forget about performance issues that we can spot during data ingestion framework processing. Also, very important thing is development efforts, because, for example, if you are writing every time for every data ingestion process, separate scripts, separate jobs, it also takes a lot of time and is a very big space for mistakes. Data governance, it also a very big problem that a lot of companies spotted today, because they have some processes of ingestion data, but they don't know where they take this data, what is their data about, and so on. So it's also very important to have some data governance tools and standard approach. It also will be good, will be a very big benefit to have like a standard approach in the company, in the organization, that will be consistent. Because if we have different, for example, regions where we develop our code, and if we have in different regions different code base, it will make inconsistency between the company. It will be a bit complex to handle these cases. So we have identified some problems, and what is our actually solution and result? Our solution will be implementing some data framework, let's call it data ingestion framework. And this system, let's assume, will be able to handle resources better, will make our data processing more efficient. It will be easy to fit into different changes, into changing business requirements, and so on. Also, it will reduce us to writing separate scripts for every data ingestion process, and it also will make for us more standard approach between the organization. And as a result, we will have the framework that have better efficiency and will spend lower costs. Okay, let's then move on to the question: what is actually this data ingestion process? Data ingestion process is a process of collecting data from different sources into one storage, into one place, where we can easily access this data, where we can use this data, and where we can analyze this data. Like, why do we need this data ingestion process? Because when all the data is together, we can make better data-driven decisions. It's like converting the data into valuable insights. By looking into the data, we can make different ML models, different AI models, different predictions. We can make data-driven smart choices. So using this good data ingestion process is really very important in the every data company. Okay, maybe you have the questions where this data ingestion process can be used. Actually, data ingestion process can be used everywhere, because everywhere we have the data, everywhere we can ingest this data, everywhere we can make some predictions on the data. But here I will present for you a couple of use cases. First of all, it's finances and banking. So it helps for us manage risks. It can make reports for us different. Also, it can improve customer experience. It can be used also in telecommunication. It can aid in improving some networks, or it can help predict us any network issues. A very big area where data ingestion process is used is retail and e-commerce. Actually, data ingestion process can support for us better understanding of the customer behavior, supply and chain management, and also it can help for us write some models that can make sales forecasting. And finally in manufacturing it also can be used, because with the latest rise of IoT, Internet of Things, effective data ingestion can help us manage large amount of production data for controlling quality and improving efficiency. Okay, let's understand how data ingestion works and what types of data ingestion we have. We have two main approaches of data ingestion. We have batch ingestion and real-time ingestion. So batch ingestion is like taking a big group, or not a very big group of data, and moving it from one place into another place all at once. So actually batch processing, it collecting some group of data and processing it at once. Real-time ingestion is more like a constant stream of data that is coming to us in real time or near real time, and we process it, not waiting for this batch of the data. For data ingestion processing, in most cases we use ETL model. So actually ETL model is the model that extracts, transforms, and loads. But for data ingestion framework is also very critical thing like data validation. So let's think how data ingestion framework must consist of. It must consist of data extraction. It's just like it sounds. We take some data from some place. It must be data validation to check if the data that we received is expected, is clear, is full. We don't have like key attributes like nulls and so on. Data transformation, it's where we prepare some data, we cleanse it, we may change format of the data, we change the column names, we change data format and so on. And loading, it's like putting this data in some persistent storage, whereas this data can be used for future needs of different models and so on. So maybe you also have the question, why why we need this data ingestion, why it's really crucially important stage in data engineering. Also, there are a lot of things why this data ingestion is critical, but let's take a look on some of them. First of all, because it serves as an interface. What does it mean? You can imagine, you can think of this ingestion process like a bridge. It helps to link our data from different data sources to the place where it processes. So actually, it brings everything together in one place. Also, it plays a huge role in enable data transition. So data ingestion is the first stage of the data processing, where raw data is transformed into meaningful information. And after we have made first stage, the very first stage of any data-driven solution, we can analyze our data, we can write different models on it, and so on. Also, it can reduce times to insight, meaning if we have some standard data ingestion framework, we have some smooth data ingestion process, we can quickly ingest data, not wasting our time on this process. Also, quality ensures data quality. It also has high quality. It ensures that our data has high quality. It ensures that we have our data accurate, full, and so on. And it means that we don't need, we will be able to detect issues on the earlier stage, on the very earlier stage that is called data ingestion process. Actually, this is some things why data ingestion is really important in any data engineering project. Okay, and also I want to show you some consequences when we will ignore proper data ingestion process. Actually, if we are going to ignore correct data ingestion process, we can have like quality compromises. It means that when data ingestion doesn't go right, we will have in the final storage not very correct data. We will have data with low quality, and it can lead that we can make not correct insight in the future. Also, integration issues come up. So without proper data ingestion, different parts of our data solution will not work together. So, and also it's very important to have good framework that can integrate with different parts of our data solutions. The third thing is impaired decision making. So when data is not ingested correctly, it's really hard to make any AI model, any ML model, because our data can be incomplete, our data can be incorrect. So we must have very good data that have the highest stage of the quality to make good insights, to make good models. And finally, we can also spot on the compliance risk, sorry, because if we don't have correct data ingestion, we can split with the legal issues. Okay. After we understood what is this metadata, what is this data ingestion, why it's important, the problems that we might face, now I want to give you some understanding what is actually metadata and what is this metadata-driven approach. What is actually metadata? If you're going to take a look under the table that is on the slide, you can see that we have some data. We have some name, age, title, and so on. So actually here on the slide, Andrei, Senior, 22, everything is a data. But metadata actually is the same data, but metadata is the data that describes our data. So for example, we have the column that describe that this column will contain names. We have the column age that describes that this column will contain age. So on the screen on the right, you can see what can be metadata. Metadata can be table name, can be column name, can be column data type, can be any primary keys, and so on. So whenever you see term like table name or column name or others, you can think that it is metadata. Also, how it can be used in data ingestion process. On the screen, I have two different images. Let's take a look first on the left one. So it's actually a traditional data ingestion process. It means that for every data source, for every table that is coming to us, we have to create separate code, separate script. For example, if we have consumer table, it means that we have to create script for consumer table to be created somewhere. If we have transaction table in SourceDB, we have to create separate code for script for the ingestion transaction table. The same for loyalty. So for in traditional data ingestion process, for every data entity that comes to us, we need to write separate script. But if you're going to take a look onto the right image, you can see metadata-driven data ingestion process, where we have single set code that is driven by metadata. So we have, as you can see here, some table, let's call it metadata table, that stores all needed information for us, like where to take the data, where to put the data, how to check correctly data quality, how to make transformations, and so on. And by using this metadata-driven data ingestion framework, data ingestion process, we can have one single code set that is driven by metadata tables. Actually, this is explanation how this data ingestion, how this metadata can be used in data ingestion process. Now I want quickly go through the benefits of using metadata-driven data ingestion. So it's a lot for us automation. So we can automate it by using metadata. It can be scaled. So it can easily be adapted to different data sources, to different data formats, to different data volumes. Also, data quality is also very big benefit because we can control our data quality. It ensures that our data is accurate by using metadata information, and it ensures that our data is reliable. Flexibility is also an important thing because our data ingestion process can be adapted for different data formats that we are receiving and so on. Data governance, it also can give for us control of the data. Efficiency, that we don't need to write a lot of scripts, custom scripts. We can make one script, we can make one common code set and orchestrate it and drive it by using metadata. It also make for us impact analysis. So when we have our data ingested in a very smooth way, we can make our analysis faster. Collaboration, also everyone from any team can take a look onto the metadata and understand what is data about. You don't need to go to the code to read this code and to understand what is going on. So even a business user can understand what is data about. Error detection and also compliance. If you don't track correctly sensitive data, we can also have some issues, and data ingestion framework says that all our sensitive data will be encrypted or hashed depending on the PI information, PI classification. So now maybe you have the question, what tools we have for using this metadata efficiently. Actually, we have a lot of tools, but I will present for you a couple of them. First of all, we can use SQL database for metadata management. It's great for storing core data, but it doesn't have many advantage features for data governance. Actually, it's very hard to handle different types of rules, different types of transformations, and so on. We can have Azure Preview. These tools automates metadata management, and it also works good with Azure. This is the tool that a lot of organizations is used. And finally, we have also Calibra that can be used. So this tool provides for us also very good understanding of data management control, but the problem is that it can be a bit complex to fit this Calibra into the system. So for our data ingestion framework, we will choose Calibra because we will choose, Purview, Azure Purview, because we will build our framework by using Azure portal, and this Azure Preview will be really very easy to integrate into our data ingestion process. Also, it has a lot of benefits. It's like seamless integration. It likes that it can be integrated very good. It has data lineage features that shows for us all lineage of the data from where it was taken, where it was put, and so on. Also, it supports custom metadata, so we can add any metadata, any information that we want to store in metadata, and so on. So we have covered quite a big background of the presentation. We have explored actually what is this data ingestion. We delved into the concept of metadata. We have chosen the metadata tools that we will use for our metadata storage. Now, let's take a look onto the architectural overview of the designed data ingestion framework. So let's start our architectural overview from the metadata that we need to process our ingestion process effective and reliable. So please pay attention on the slide. We have two levels of metadata. It's asset level metadata and attribute level metadata. So for asset level metadata, in this asset level metadata table, we will store all information related to specific data feeds, specific data source, specific data asset. It's like job ID. It shows for us a unique ID for the job. It's like format of the data, ingestion location. It means that from where our data must be taken. It can be processed catalog name, processed schema name. It's where to store our data. Also different information that is related to specific asset level. But if you're going to take a look onto the right, here we will have attribute level metadata. What attribute level metadata we will have? So this explains for us actually how specific asset must be handled on the attribute level. So for example, we can have source field name, target field name, description of the field column, and so on. Also, we can check if this column is PII or not PII. Also, for data quality, we can, for specific attribute, check if null values are allowed, if we have any minimum or maximum values, or any allowed values. So for the correct data ingestion process, all these fields must be filled in the Azure Preview to give ability for our data ingestion framework to take these rules from Preview and to process it. Here actually is the process of storage, collecting, storage, and utilizing this data ingestion metadata. So how actually this metadata management works? We have our data analyst that requests sample data in data provider. Data providers at the same time puts this data into ingest storage, some data from dev environment. After data providers have put the data, business analysts start analyzing this data and create new asset in Azure Preview and fills all the information, all the needed information based on the information from the data, where this data is located, and analyzes this data, if nulls can be allowed, and so on. And all this information from this table, for these tables, must be provided based on the input data in ingest storage. And actually, after it, our data ingestion framework starts processing. Okay. After you understand the process of filling metadata, let's make high overview of the diff and its layers. So as you can see on the image, we have three main layers. That is ingestion layer, that is raw layer, and that is processed layer. So let's go through them. Ingestion layer, actually it's for us is like a starting point for new data. And also this ingestion layer comes for us with retention policy. So it takes ingested data just long enough for it to be processed and move it forward to the next layers. For after ingestion layer, after we receive the data into ingestion layer, we have raw layer. Raw layer we have decided to split into two parts, is raw ADLS layer and raw Databricks layer. So what is raw ADLS layer? Actually, it's a place where we physically store our files, our data. We take data from ingest layer, put it in raw. But maybe you have the question, why we need this raw layer if we have ingest layer? Because ingest layer has not a very big level of security, because in ingest layer data can be unencrypted, and also it has retention policy enabled. So it means that we need some permanent storage where we will have secure data process with secure data. We will have all our data, PII data encrypted or hashed. For that, we have raw layer IDLS. So we store their files from ingest layer, but it is a permanent location, first of all, and second, it has all PII data encrypted or hashed. Also, we have raw Databricks layer. So actually, it's this part. It includes for us creating an external table on the raw data in ADLS. Actually, this layer is more for some business user, for some analysts that want to analyze raw data and they don't need to go to the raw files. They can easily query by a simple SQL query some table. After raw layer, we have processed layer. Actually, this is the last layer for data ingestion process. It's Databricks processed layer managed data table. In this process, we have data that has gone through validation steps, through transformation steps, and is stored in the last layer that is available for the next teams to be taken, to be processed, to be taken, to be analyzed, and so on. So also we have curated level in our medallion architecture, but a curated level actually is out of the scope of data ingestion process because it needs some business logic to be implemented. It must be done by joining different tables and so on. So our data ingestion framework works only up to processed layer. Also, all these layers are connected through Azure Data Factory pipeline that has ADF Databricks activities inside that runs Spark jobs for us. So yes, this is high-level architectural overview of the diff, and you can also see how each layer plays a critical role for us. Next, I want to show for you quickly logical levels of the data that diff supports. So the highest level of our data ingestion framework is job ID. So job ID, it must be something unique through our platforms, through our organization. Our job ID is like application we are running, can be divided into different groups. So we can have, for example, job that we need to run one part in the morning, one part in the evening. For that, we can divide our job ID into different groups, group 1 and group 2. Then our groups. We can divide our groups into different data source systems. So for example, let's assume we need to ingest offline data. If we are working in some e-commerce and we need to ingest offline data. Offline data can come to us from different data sources. It can be like some Google, some Facebook, and so on. Yes, our group can be divided into different data sources. So we can ingest data from different data sources for offline data. Also, this offline data can have split between data feeds. So one data source system can have multiple data feeds. For example, offline data can be offline consumer data source feed and offline transaction data source feed. It means we also give ability to split our data source system into different feeds. But very important to mention that data source feed can have only one ingestion path. It means that offline consumer data can want to one location, data source feed for offline transaction can go to another ingestion location. Also, we can split our, for example, the source feed, like we have consumer information and we want to split it into separate assets. We want to have asset consumer email, we want to have asset consumer phone, and also we give support of such operations. We give ability to split our data feeds into different assets. So, and the data assets can have different attributes. So let's summarize. We can have, for example, offline data that comes to us from different data sources. For this offline data, we can have different feeds like consumers offline, transaction online, and this data feeds also can be split into different assets. So we can have email asset, we can have phone asset with multiple attributes in it. So frameworks designed actually to give for us maximum flexibility, but it's in most cases you may assign one data feed for one job, and the framework will also give ability for this. So you can make like different offline data to make different job IDs for this offline data. But if you want to place it into one job ID and to want to run it by using one trigger, you have this space to do it. Okay, now let's review a bit the data pipeline process. So here on the screen, you can see how this data pipeline process acts. The first stage, the first step is ADF trigger. So we create trigger that can trigger our data pipeline, master pipeline. This can be any triggers. It can be time-based trigger, event-based trigger, and so on. This trigger also have to provide for us the information about the source we are running, the job we are running. Actually, it must have job ID, and also it must have configuration. Also, we can have data asset, but it's more like optional parameter. This trigger triggers our master pipeline, and master pipeline start is processing. First of all, master pipelines take needed information from Azure Purview. The pipeline retrieves all information for orchestration about our job ID. We take information for the feed level and for the asset level. We need this because we want to process our data ingestion pipeline in the most efficient way. So for that, we need to use for each activity that is in ADF that will for us to parallel our jobs. So actually, our feeds are independent. It means that we can take our data feed and run all data feeds in parallel. For that, we are using for each activity in our ADF pipeline, based on the metadata for preview. So for specific job ID, we check how many data feeds we have in specific data job. If we have 2, 3, 4, we will run it in parallel. Also, we have inner also for each activity, because as was presented on the previous slide, between in one feed we can have multiple data assets. For that, yeah, we also created for each activity to run every data asset in parallel. So phone, email, core, and other data assets can be run in parallel. This is like very quick overview of data pipeline process. Also, we have SQL database for storing some technical metadata. It will be also described a bit later. Now let's make a bit dive into a comprehensive view, make a comprehensive view of the ingest to row job. Actually, yes, as we described here, we have ingest to row job that is working on the feed level, and we have row to process job that is running on asset level. So let's take a look onto the first, ingest to row. Actually, the stage begins with reading metadata from different places. We read metadata from Azure Purview to have all information about the data feeds that we are running. We are reading all information from ingest layer, ingest storage to understand what is new data, what's data we have processed, and so on. What actually is the data we have to run. And we also read metadata from SQL. It's technical metadata that gives for us understanding what data was already processed, what new data is, what needs to be reprocessed, what was filed, and so on. So by using these three types of metadata, we make such process that is called source file profile detection. Actually, it like a rules that shows for us what to do with specific data feed, what to do with specific files, what to rerun, what to run from scratch, and so on. So after we have created this list of rules, we have source file level actions. Actually, we read our data from ingest layer. We perform deserialization because we support different. We can receive data in different formats, in XML, JSON, CSV. So for that, we have to deserialize our data. The very critical step is source validation. We perform different basic validations that our data ingestion framework supports. But also very important thing to mention here is that our data ingestion framework supports customizations. So if, for example, custom basic standard validation rules that is described into metadata is not suitable for your use case, you can override the source validation class and to write your custom validation by putting it into the correct location. The same can be done for transformation. Also, to ensure that our data is stored into the secure way, we have attribute protection. We make different types of protection like encryption or hashing depending on the information in the preview. So for every field, for every attribute, we have information how to act with this specific column. How to encrypt it, what type of encryption use, what type of hashing use, and so on. Also, we have serialization back to the format that we have received. Also, to have one more level of security, we have file protection. So we also encrypt our files, and also after these files are encrypted, we put it into raw layer, and we are updating our SQL database with technical metadata that this specific process has been finished. Okay, it's a deep overview of how our data ingest to raw step is working. But now I want to go through all components more deeply. So, serializer and deserializer. For managing this process, we decided to adopt design pattern known as a factory pattern. So how it will work? Our framework will support 6 data formats. It will be JSON, CSV, XML, Parquet, Excel, and TXT. So to handle these varied formats, we have interface that is called serializer that have actually 2 abstract methods, that is serialize and deserialize. Under this serializer interface, we have 6 classes that allow us to support different formats. So we have JSON serializer, we have CSV, XML, and so on and so on. So this allows for us to handle different data formats. Also, we have class serializer factory that actually is a factory and creates a specific format depending on the input file format. So that is stored actually in our metadata. So depending if our format is JSON, it will initialize for us JSON serializer. It is CSV, it will initialize for us another class. And we will be able to have two methods implemented, serialize and deserialize. Also, why this design pattern factory was chosen? Because it provides a flexibility for us and efficient way to handle different data formats. And it also can be scaled easily by adding new formats if we have something in the future. Okay, standard and customizable data validations. So for standard, as I said, we have validation for nulls, if this field can be null, cannot be null. We have min and max value checks, and we can check if we have allowed values. But also we can have extensions that can, if, as I said previously, the standard validations like that was described doesn't match your case and you need to add some more validation to your files, you can do it. Actually, you can do it by creating your custom class. Also, we have added support of 2 customizations. First is to append logic to existing standard or to override everything at all. So depending on the use case you need, you have to create the specific class that must be called as asset name and validation or transformation. And if you need to add some new validations, you have to implement execute custom extension method. If you want to rewrite everything, you have to implement execute extension method, and it will allow for us to add these custom extensions to our validation or transformations. And also job will be automatically, this also classes must be put into the specific location, and while running the pipeline, job will automatically see if we have any extension for specific data asset or we don't. Okay, next step is row to process step. After ingest row is completed, we are running row to process step. Actually, it's on the same start, it acts in the same way. We read metadata from preview, from SQL database to understand what files, what sources we need to run, what ascents we need to run. The process is the same. We read by using raw data loader, read the data. We perform deserialization. Also, as you remember, in ingest row stage, we have encrypted our data. And to perform correct transformations on the specific attributes, we need to make decryption of the attribute. With decrypt attribute, we perform standard data transformations. Also, we have support of custom data transformations. After we perform standard or custom, we perform again encryption, and we load the data to processed data by using processed data loader in a processed delta table. So here is also overview of the standard processed data transformations and how our processed data loader works. So for standard data transformations, we have changing column names from source to target. We have ability to cast our data from source column type to target column type. Also, we are able to coalesce the same columns. We can we replace our blanks with nulls. We can also apply some derivation rules from metadata if they are there. We remove null records if we have some specific flag in Azure Preview for this attribute, and we remove duplicated records if also we have a specific flag for it. After we have performed all these transformations, we are moved to stage that is called processed data loader. So processed data loader, first of all, it adds for us checksums, columns, and meta fields. Actually, our processed data loader uses CDC process. So all our data assets must have specific CDC option. So about CDC, we will display. We will take a look on the next slide. But here we have to base it on the key fields, create key checksum. That is the hash of the key fields. And for non-key fields, we have to create non-key checksum. And by writing new data into our processed layer table, we will be able to automatically complete if we have already such a checksum, key checksum, if we don't have such checksum, and we will be able automatically handle CDC. So by adding this meta fields, we apply CDC depending on the type, and we merge or write information into delta table. Also, we create a view with dynamic decryption feature enabled. So it means that some authorized people that have like more accesses can view decrypted data in this dynamic decryptor view. CDC. So actually, we in our data ingestion framework, we have support of 9 CDC types. You can see them in the columns. Actually, yes, CDC types depending on the different different scenarios. So if deleted for our data is required, what data we are receiving, if it is full snapshot of data or incremental snapshot of data, what actions we want to have, and also what SCD types we want to have. So for example, we need to delete the data, we need to have full snapshot of data, and we want to make actions like IUD, insert, update, and delete, and want to have T4, for example, SCD type. So for that, we need to use T4 IUD CDC type. So also, CDC types are implemented by using factory design pattern. So we have CDC interface, and we have implementation of every CDC type. This interface has two methods that are called compare and execute merge. And yes, we for every CDC type, we implement this function, and by using the factory, it initializes the needed for us class. Okay, Next topic is metadata storage, technical metadata storage. For technical metadata storage, we have Azure SQL database. There we have 6 tables. Let's quickly go through them. We have batch detail table that keeps information about the files that we are running, the statuses of the validation of the files, and so on. We have asset detail and feed detail tables that stores for us information about feed and asset we are running. We need these tables because we have process detail table that acts like a bridge between batch detail and asset detail. And for every process detail, for every job, for every asset that we are running, we have to provide unique asset ID and unique feed ID and unique batch detail. So actually, this processing detail table stores information about the asset IDs that we are running, about feed IDs that we are running, the batch ID, so it means that files we are running, and also the status of our run. Also, we have 2 more tables where we store the statuses of the pipeline, its pipeline run detail, and all available statuses in status detail table. So I think we can stop here on this metadata review, but if you need more details, you can review this slide after the conference. Okay, let's sum up. We have in our architectural overview such functional components as ADF execution pipeline, we have Azure Preview, and also we have metadata database. For technical things like to know what is going on, what's happening, we have logger and alerter. For custom extensions, we have custom validation, custom transformations. For core, we have ingest to raw job, raw to processed job that actually handles everything. We have 3 data storages. It's ingest, it's blob, it's raw ADLS. It's the same raw but Databricks external table based on the raw data in ADLS, and also processed layer table. And common functionality for validation, encryption, decryption, reading, attribute protections, and so on. Last thing here is maybe you have the question, does our data ingestion framework support ingestion from data sources like SQL, SAP, Oracle, and so on? So to answer this question, we need to understand what is this pool and actually what types of data providers we have. On the screen, you can see that we can have 2 types of data providers. It can be pull and it can be push data providers. Push data providers is pretty easy. They push data to us into ingest layer, and our master pipeline diff starts running this ingest data. But if you're talking about pull data ingestion process, it means that we have to take data from our data provider. We have to connect somehow to data. We have to connect somehow to SQL Server or to SAP and to take data for this. For this, we need to implement like some custom pipeline. So first of all, to connect to the data, we have to use linked service. So Azure Data Factory has such feature called as linked service. So by configuring this linked service, we can connect to different data providers, to SQL servers, to Oracle servers, to SAP, and so on. Also, for this linked service, we have to create specific source to ingest pipeline. It means that for SAP, we have to create one SAP source to ingest pipeline. For SQL, we have to create another source to ingest pipeline that will link to specific linked service and will copy data into ingest layer. It's actually a quick overview how pull mechanism can be implemented by 2 stages. First, creating linked service to a specific data provider, and second, by creating source to ingest pipeline that have copy activity inside that will be able to copy the data from source provider and put the data into ingest blob storage. And after it, master pipeline must be triggered. Okay, here is the benefits and key features of data ingestion framework. Let's go quickly. So it's metadata driven. It has data and file protection. It has some technical things like logging and alerting for debugging. We have file validation that assures for us data quality. It has parallelism that allows us to process data quickly and efficiently. We have different scheduling options. We have support of multi-day runs. It means that we support different various of frequencies from every 15 minutes to yearly. Restartability is the feature that allows us to start pipeline from the place where it got failed. So if, for example, for specific data asset ingest to raw step is completed and it failed on raw to process, we will not rerun ingest to raw for this pipeline. We will run ingest raw to process step. It supports metadata-driven transformations. Also, it supports 9 CDC types that give for us very big flexibility in our data manipulations. Also, if standard validation and transformation doesn't fit for you, you can write your custom extension. And also, we support different data formats, as was mentioned: XML, JSON, CSV, Parquet, Excel, and TXT. Okay, let's take a look onto the future perspectives and make conclusions. So for future perspectives, we can implement anonymization. So anonymization actually is the process of protecting personal data by making it impossible to connect it with a specific person. So in other words, is a way to use meaningful data while keeping private information safe. Also, we can add some AI enabling. So it refers to integration, intelligence, artificial intelligence in our framework. So this can improve for us ability to analyze data and make better decisions. Also, we can think, and we are in progress with designing better source to ingest part, actually, to be able to make it more metadata driven, because currently it's semi metadata driven, it's semi metadata driven savvy manual process. And conclusions. So we have designed metadata driven data ingestion framework that gives for us metadata driven workflow. It means that we have common script that takes metadata from purview. We have structured data procedures. It means that we have our jobs divided into two parts. It's ingest to raw and raw to process. And also, if source to ingest is needed, we also have this here. It incorporates advanced features. It means that we have multi-day reruns, we have restartability, we have CDC enabled, we have alerting and other advanced features. Extensibility and customization. So we can add custom extensions for validation and transformation if standard one doesn't fit for you. Security and privacy. We also have encryption and decryption mechanism on both file level and attribute level. And also we have flexible CDC handling. So we have a lot of CDC types that offer for us maximum flexibility in managing our changes into the data. Okay, that's it from my side. Thank you for your attention. Maybe
Great, but don't leave us yet, right? So I have a question from my side. So a very detailed framework description, right? So when you say we have developed a framework, can you name the specific group of people who have developed this framework and what practice or what unit you're representing? Because maybe there is some ambiguity to our listeners, right? Because some of them don't work in EPAM. They want to know more about this.
Actually, it means that not only I was working on this architectural overview. There was some group of people on the project that were working on specific data requirements or specific requirements of the framework, on specific features, and we all gathered all requirements from different places and developed and architectured this data ingestion framework.
Okay, so this is not a generic framework from data practice of EPAM, right? So this is a framework developed specifically on a concrete client project, which keeps in mind specific problems you face during the project delivery, right?
Yes, you're right, but the framework was designed to the way that is flexible. It can be adapted to any client, to any solution, and to any data formats and so on. So we have tried to develop as much universal framework as we can.
Okay, couple of questions from our listeners. Not much time left, so let's keep it short. Larissa Matolinets is asking about data contract. So I don't think this is related actually for data ingestion on data platforms, but maybe you can comment on this. Have you worked with data contracts? Which tool to use? Because I think data contract is more about applications, right? It's not about
actually Yes, I had a big experience, not a very big experience in data contracts. Yes, we have used Calibra, and there we have made this data contracts for another framework that we had developed. But actually, for this data ingestion framework, we don't have the data contracts.
Exactly, exactly. Yeah. But in general, yeah, of course you have them, but
Yes.
data ingestion is basically pouring all the data, to the data platform, right? It's not about apps talking with each other.
Yes,
okay.
You're right.
So Larissa Matolnitz, another question. Okay, maybe we'll skip and another listener, another participant, Nadia Birban. So what do you call decision in your simulations? So there were like simulations you talked about.
And decisions. So actually, need to find this slide.
Yeah, we need to find the slide, I guess.
Don't remember where is the slide is. Sorry, 1 second. I need to find it. Decisions. Maybe here. Decision making. It means that if data ingestion process is not correct, it will be hard to make some decisions. Actually, how we have to work with specific user, what decision we have to make for specific campaigns if we have, and so on. So it's like more not about data ingestion framework, it's like consequences of data ingestion framework. So for the future streams, like we can have ML stream, we can have AI stream, and if our data ingestion process is not very correct, it will be very hard to make any decisions, any insights for specific products that we are building. This is about this.
Okay, another one from Larissa. Could you give an example of the situation where the metadata was an absolute beast that saved the game? The classical example for me is Parquet metadata that helps a lot to optimize computations. I think most of the presentation was about that, but maybe,
yes,
let's
I can. So actually, as was presented, not only Parquet is a data format, because there are really a lot of systems that supports different data formats. XML is very popular, file format. CSV, Parquet also can be used, but there are old source systems that doesn't support Parquet for us. For that, we need to adapt our data ingestion framework to support different data formats, not only Parquet. And for that, we will have the tool, we will have the data ingestion framework that has supported a very big amount of data types, and we can, by easily providing information into the metadata, ingest our data. Something like that, because not only Parquet are used in data ingestion. A lot of files format are used.
So you mean metadata can save the game practically with any technical stack, right?
Any technical, yes.
Okay.
We don't need to write separate scripts and so on for specific data formats. We already have it developed.
Marina Mars, does the framework support real-time data ingestion, or batch processing is supported only? So what was your experience on that project?
Actually, no, data ingestion framework currently doesn't support. It was presented already on the slide that currently data ingestion framework supports only batch processing, but we support only also, I need to find the slide. Yes, we have two types of data ingestion, yes, real-time and batch ingestion, but currently our data ingestion framework has support only for batch processing, but the minimum time between runs can be 15 minutes. But yes, it's a very good question. We can think on implementation some autoloader feature or that will provide for us ability to have this real-time ingestion. Currently, we don't have this real-time ingestion, only batch ingestion, but in interval, but 15 minutes between the run. The minimum interval is 15 minutes between the run. What I think is good for data processing, for data engineering.
Okay, got it. Thanks. What about other cloud vendors? So Azure, Databricks, understood. So do you think this is your experience and the framework you develop applicable to AWS, GCP?
Yes, we can think. We can think on moving to different Azure providers. This framework also can be developed on GCP and AWS by using the same technologies in AWS. For example, we have Databricks in Azure. We have the same Databricks in AWS, so we can use it actually the same storage. We have, for example, in Azure we have blob storage or ADLS. In AWS we have S3, so it will be the same solution, the same architecture, but only we will use like the different technologies, but they will have the same logic.
Yeah, you even have Databricks on GCP, right? So I mean,
yep.
Sure. And the last one from, because we're short on time, from Pure to Dam. In terms of times and costs of the delivery, I suppose, would this framework be faster to create, or the costs are higher than usually? Yeah, this is a big question. What means business as usual, right? In that sense.
Yes, actually.
So, I mean, yeah, it's a question, I think, of the repeatability of the frameworks. When you have them, so does it help the teams to deliver faster, right? And at less cost?
Yes, you're right. So actually, to implement this framework will take some time, but we will have already framework that can be worked for 5 years, for 10 years. We will not, after we have developed this framework, we don't need a lot of developers that will support this framework. We can have, for example, one developer that will fix some bugs, will make some enhancements and so on. So we will save the cost for future. For developing, it will cost some money, but in the future, while our framework will run for a couple of years, we will save money for creating for ingesting new data sources.
Cool. Okay. Thanks a lot. Thanks a lot for your presentation. So that was Orest Chukla joining us from Lviv, Ukraine, talking about the data ingestion frameworks they have created with the team on a real client project in EPAM. Orest, who had the best question? Who will be receiving the LinkedIn Premium subscription?
Actually, I like it the most the last questions about the costs, because we are doing everything to save our money, the client's money, and I like this question the most.
Okay, so YouTube user named Peterdam, please reach out to our contact posted right now in the YouTube chat to receive your free subscription. So thanks a lot, Orest. We finish our session on that.
Thank you.
So thank you for joining us. Up next, we have David Ayala from Colombia, who will take us on a deep dive into Crew.AI and how it empowers AI agent to elaborate on solving complex tasks. Stay tuned for insights and practical examples. We will rejoin in 1 minute.
You grow. You grow when you have a desire to become better, to learn new things. When you listen to a webinar, a conference, a talk, go to courses, dozens of courses, then you are the one who speaks. You grow. You grow when you get up to speed. When you focus on your work, on your customer, on your team, then you become a part of something big. When you raise the bar and take responsibility for your work, whether good or bad, when they ask you for advice, when you create a small revolution or speed up an evolution, then you grow. You are growing because growing matters to you. You keep at it until it's just right. To be honest with yourself and others, to further educate yourself, to become an expert. And if it matters to you, it matters to us. APAM, focus on your growth.
Hey everyone, and welcome back to the EPAM Data Autumn Conference 2024 Engineer Expertise Unleashed streams. This is the last session of our stream for today, and we'll be hearing from David Ayala, a senior software engineer from Bogota, Colombia. He will be speaking on a topic which is named Deep Dive into Crew.AI. Develop a multi-agent AI systems. There has been a lot of hassle about AI agents, so I'm very keen to listen what David has to say. David is a machine learning engineer with a proven track record in building advanced machine learning solutions and LLM-powered applications. So he will explore how Crew.AI enables AI agents to collaborate on solving complex tasks. He will break down the framework's architecture, benefits, real-world applications, complete with practical examples from his real-life experience and code snippets. So, David, are you with us?
Hello, everyone. Yep.
Hey, good.
Hey.
It's 8 a.m. in Bogota. Am I right?
Yes, it is.
Are you an early riser?
Sorry?
Are you an early riser normally?
Yeah.
Yeah, so you're okay. So you're,
Yeah.
at your
Yeah,
full speed already running.
yeah.
You have
Yes,
enough
yeah.
caffeine, right?
No, yeah, I'm ready.
Cool. So let's hear about this AI agent. Personally, I'm very interested because I think the industry awaits the next step in AI technology. Please, you can share your presentation.
Yep, sure.
Everyone, don't forget to ask questions in the YouTube chat. We will also choose the best question. David will choose actually, and the one who had the best will receive the LinkedIn Premium subscription. So please be active in the chat. Let's hear out David.
Cool, awesome. Thank you for the introduction. Okay, so let's jump into it. Okay, let me know when you're able to see my screen. All right, so well, thank you for this opportunity to talk about Crew.AI and how to develop multi-agent AI systems. Essentially, Crew.AI is a framework that's developed in Python, and yeah, allows you to build multi-agent AI systems. So, all right, this is pretty much the agenda we have for today. We will start with some brief introduction. We will talk about what's a multi-agent AI application. Next, we're gonna make, or I'm gonna present our first demo, which is an event planner, and it essentially shows the basic functioning of a Crew.AI. Next, we are gonna see how these agents collaborate to each other, and we're gonna talk about flows and memory. We're going to have also a second demo about flows. Finally, we will see what's the Crew.AI command line interface and how you can deploy those crews into production using the Crew.AI infrastructure. And we are going to wrap up with conclusions and the QA session. Okay. So first of all, we should start by talking about what is the multi-agent system. So essentially, the thing here is that we have a complex task that needs to be solved by AI, and then we need to break that task into smaller subtasks that are more manageable. We are going to build agents that has some specific role to execute those subtasks. So an example of that can be, for instance, an SEO content workflow, and the agents can be some kind of keyword strategies, then a research content creator, and a fact checker. In that way, we can solve a complex task using agents in charge of a smaller and simpler task. Another example could be, for instance, a project planner that break down tasks. Then we can have an estimation analyst and resource allocation analyst. This kind of approach can be applied to many domains. For instance, in the financial context, you can make a stock analysis and recommendations, but by having an agent that is in charge of reviewing the market data, the company performance metrics, and some agent in charge of the final recommendations and the economic trends. So we will see one of these agents in the demo of these crews. So this is pretty much the idea of having a multi-agent AI system. Okay. Now, what's Crew.AI? Crew.AI is an open source Python framework, and it's actually an entire platform that you can use to coordinate autonomous AI agents with distinct roles. So Crew.AI is built on top of LangChain. So if I had to compare LangChain, LangChain and Crew.AI, I would say that Crew.AI is a more higher level framework. It abstracts a lot of details that we have in LangChain agent development, and it's more focused on enable agents to interact with each other. So the advantages of Crew.AI, it's essentially that you can have some role-playing agents. As I mentioned before, the agents can take different roles and personas to tackle one of the simpler tasks. They are autonomous, of course. They are AI agents, so they can make autonomous decisions. You can also equip those agents with tools, and they are autonomous to decide when to use those tools, which is also great because you can then use tools to integrate with your internal systems or external systems, make some kind of queries, search the internet. There is plenty of tools available. Another good thing is that Crew.AI integrates not only with, of course, Crew.AI tools, but also LangChain tools. So the ecosystem of tools is huge. There is seamless collaboration as well because the agents can work together. They can share information between them, sharing resources, and achieve common goals. So yeah, that's pretty much Crew.AI. It's a framework that put these agents together and also put those agents into production. So let's now dive into what's an agent actually. What's an agent? So agents in Crew.AI are essentially React agents. The idea behind React agents is that they have a task, and first they need to think how to solve that task. Once they think, they choose a tool. If they have available tools, they choose a tool, they act, and they observe what's the output of that tool or what's the output of that action. When they have this observation, they repeat the loop. So they update the context with the result of that observation, and they repeat the loop. So yeah, that's pretty much how a single agent thinks, let's say, and what's that a single agent do in the framework. Now the thing is that we can have, of course, multi-agent AI applications. So we have different kind of agents with a role, a goal, and a backstory. That's part of the framework. You have to assign those three elements to the agent. You can also assign tools. But then on the other side, you also have tasks. The tasks are described with, yeah, they have description, they have an expected output, and they have an agent that it's assigned to solve that task. So yeah, essentially the role of the agent pretty much defines the agent's functions within the crew. The goal is the individual objective that the agent must achieve. So basically, yeah, that goal, that's what guides the agent decision-making process. And the backstory is just to give the agent more context about the role and goal. So it's a way to enrich the information we give to the agent. Yeah, the description, what's the task to achieve, and the expected output that can be a structure or unstructured. And that's, I mean, when you put those elements together, that's what it's called in the framework a crew. So yeah, that's a multi-agent AI application. And I think it's time to jump into our first demo, that it's an agent planner, to see how it actually works. So, okay, so in our first demo, we're gonna make an event planner. It's just to show the basic functioning of Crew.AI. So here we will have 4 different agents that will interact to each other in a sequential manner. First, we will have a venue coordinator. We will have also a logistics manager, a marketing and communications agent, and a manager who will make the decision if the event proceeds or not. So first, we start with some imports. The basic import, I mean, the building blocks of Crew.AI are these three classes: the agent, the task, and the crew. We're also going to provide our agents with tools to scrap a website, and also a Serper Dev tool that is essentially a search engine. We're going to use GPT-4o Mini. We instantiate our tools, and we start the creation of our agents. So as you can see, we have to provide role, goal, tools, and backstory to our agent. In the case of the venue coordinator, it will be in charge of booking and essentially search what's the correct, the most appropriate venue for the event. That's the goal. And you also have to provide some kind of backstory to give more context. It's similar to a system prompt to the agent. And this venue coordinator is essentially in charge of finding the place and making sure that it's appropriate for the requirements of the event. Then we have logistic and operations specialist that it's in charge of ensure that the equipment is appropriate and that there is no any kind of logistical issue. So it's in charge of managing the catering, the schedule, technical setups, all the equipment, all stuff like that. Finally, we need to communicate we also need to communicate or market the event. So we also have an agent that will be in charge of that, create some kind of content that promotes the event, either in social media or whatever. And yeah, it also has the scrapping tool and the search engine tool. And finally, we have our agent that is in charge of deciding if the event is a go or not go. As I mentioned before, we can have a structured or unstructured outputs. In this case, we are going to have a structured output, so you can use Pydantic objects for that. And let's now define our task. The first task is find a venue that meets some kind of criteria. These placeholders here is the data that we input to the crew. Yeah, here we have the first task that it will be assigned to the venue coordinator, and the output is a structure. We're going to save the output in this JSON. The logistics task, it's essentially assigned to our logistics manager, and the task is to make sure that the venue is appropriate for the expected number of participants and that it's available in the tentative date. The marketing task is promote the event. Of course, you can enhance these prompts to make whatever you specifically need. For instance, if you need a social media post or a blog post or whatever, you can specify that in the prompt and assign some kind of a structured output. And the final task is the sign-off task. It's assigned to the event management manager agent and decides based on all the information that it was gathered if it's a go or not go the event. This is the event data object that I mock up here. I'm just pretending that the EPAM data autumn conference is in presence. So some kind of description of the event, where it's going to be the event, the day, the number of participants, budget, and what's the type of venue. And the last thing we need is to actually create our crew. And the crew will be composed of the agents, the tasks, and that's it. We here say that it's a sequential process because we need to execute the agents in a sequential manner. So that's why we have here sequential, but we will talk about these kind of processes later because we can have hierarchical or other types of processes. And lastly, we need to kick off our crew with the input data. Here I already executed the crew, so here it's the execution. We can see how each agent is thinking and acting. So the venue coordinator thinks, okay, I need to start searching the available venues in Bogota that can accommodate the conference. What I need to do, okay, search the internet. What's the query? Conference venues. And then it starts collecting information. So this is also important because the agents are reliable. Are error, failure. They can handle the errors of the tools. So if they encounter an error tool, they can execute that again with a different query or stuff like that. So here, for instance, the venue coordinator found it started scrapping some of the websites that it got in the initial search, and this is how it's iterating and making some kind of loop in this React. So finally, the venue coordinator think, okay, I have found what is the it found a good place. So the final answer is like the Hilton Bogota Corferias. It's known place for this kind of events. It grabs some data, and then it passes the task to the marketing and communications agent that starts making the same loop of think, act, and observation. The logistic operations start making its task, and let's see what's the final answer for each agent, because here we have a lot of places and information grabbed from the websites. The final answer of the logistic operations specialist is that for instance, meals can be booked with this, I would say, company. It's Show Meal, and the other one for the equipment is 11 Producciones. That's the name. And it's kind of found what's the people that the team can contact to book them the equipment. And same thing for marketing and logistics and communications. So we kind of develop a strategy to promote the event. And finally, the task is that the event manager needs to decide if the event is a go or not go. So it evaluates different aspects of the output of the previous agents. And it says that in conclusions, considering the logistic marketing strategies and budget, so it grants the final approval for the conference for the event as it was planned. So this is pretty much how you can put agents together to interact with each other. And as you can see, it was a sequential process, and they were interacting in a streamlined and seamless way. So I think, yeah, that concludes our first demo. We're gonna proceed with the presentation over here. So now focused on collaboration. In our demo, we saw a sequential collaboration manner, but we can have multiple ways of the agents being collaborating together. The other one is hierarchical. There is like an agent that is like assigning workload to the other agents and essentially monitoring and distributing the work. You can also have crews that work in parallel, so two sequential processes at the same time. But you can also have some kind of hybrid collaboration. Here, yeah, here you just need to have some kind of agent that is like the manager, and there are like two options in Crew.AI. You can have either an LLM that it's like a judge or like the manager of the other agents, or you can build your own agent to do that with more context and more, let's say, specific goals and tasks for that. So that's the way that these agents can collaborate together. There is another important feature in Crew.AI, and it's called flows. And essentially, a flow enables you to integrate regular Python code at any stage. So that means that you can have Python code running before, during, or after the crew execution. This is important because it allows more flexibility in case you need to grab data from somewhere and you don't want the agent to do that explicitly using a tool, but you can do it using just regular Python code. And yeah, that allows you to create more robust automations, and you can coordinate your coding task and the crews. Using flows, you can also have some kind of paths. For instance, if there is an output of an agent and you need to evaluate that output, you can say, for instance, that given the output takes different paths or a different crew needs to be executed. So that's also possible using this feature. Other important thing in the flow is that it has a global state that can be shared across different stages of the flow, and it makes very easy to share information between the tasks. Yeah, it's an event-driven architecture because essentially each step is listening to the output or to the completion of the previous steps and can trigger the next one. It's flexible, and it also allows that the input is flexible, uh, in the sense that we can initialize our state, and it's a really cool feature when it comes to flexibility. Sorry. The other good feature we have in Crew.AI is the memory. So you can add memory to the crews. It essentially empowers the crew with more context, entity understanding, and experience accumulation. There are different types of memory. The short-term memory, um, which is a rack. Um, it uses Chroma by default, and it stores recent interactions. The long-term memory stores information from past executions of the crew, and it uses SQLite 3. The entity memory stores information about people, places. Contextual information memory, sorry, is a combination of the types of memory that I mentioned before. And user memory saves user-specific preferences and information. We have seen, I mean, we see something similar in ChatGPT when I asked, for instance, that the output needs to be always in, I don't know, JSON format, then that user preference is updated. Why memory is important? Because, yeah, of course, it gives us like contextual awareness, the experience accumulation, and the entity understanding to enhance the context and knowledge of our agents. Okay, let's jump into our second demo. Our second demo will be a pre-screening agent. So a CV pre-screening agent and some kind of, we will have two crews. One crew that makes all the pre-screening process, and if it's let's say a good candidate, then it will craft some interview question and a coding task. So the other good feature we have is that in Crew.AI is that we not only need to define our task and agents in the code, but we can also use YAML files to do that. For instance, in this structure, we define the agent, the role, the goal, backstory, all the parameters, and we pass them to the Python object that represents the agent. So in this case, we will have the agent tasks, the agents actually of the first crew, that is the CV pre-screening. We load that configuration for the interview as well. We define some structure output for our pre-screening model, that it's the output of the first crew, and we start building the crew. So we create the agent. In here, we will have two agents in the pre-screening crew. That it's profile matching agent. It's in charge of ensure that the candidate profile aligns with the job requirements. And the other one is the CV screening agent. It's in charge of identify red flags. And yeah, that would be the two agents that we will have for this demo. Okay, so the tasks are candidate profile matching and essentially searching for some kind of red flags. We then define our crew, and the other crew is the interview preparation. That is first in charge of, I mean, one agent in charge of creating some questions, and another one in charge of creating the coding task. We create our crew and we start creating our flow. In the flow, we have two main annotations here. The start annotation, of course, it's the one that defines what's the entry point of the crew. And it's essentially regular Python code to load data. And here I'm loading the candidate CV and the job description. This CV was generated by GPT-4, so it's made up, not real CV. And then the job description, I took it from the website. Then here we have the listen annotation that it's essentially saying, okay, when the load data function finish, trigger this function. And that's how you build this kind of graph of the execution of the agent, of the flow, sorry. And here we kick off our crew, we update the state with the pre-screening analysis, and then triggers another regular Python code. Here, for instance, if we want to call some external API to update the status of the candidate in the database, we can do that. And finally, the interview crew that I mentioned, it's in charge of creating the questions and some coding task. So you need to kick off the flow and we will see the execution. So yeah, first the candidate profile specialist starts its task by checking that that profile meets the requirements of the job. Well, this is the entire prompt. So this is the job. This is essentially the instructions given to the agent. It loads. This is the entire prompt, so it's loading as well the CV and the job description. And well, this agent doesn't have tools, just for the sake of simplicity. But the final answer of this agent is that the candidate profile matched the report, the job requirements, and it provides some kind of report with different aspects in terms of the programming language experience, MLOps experience. By the way, yeah, the job description was about machine learning, so that's why it's like depicting all these aspects here. It also provides some kind of strong points and weaknesses of the candidate, and then it passes the task to the next agent in the crew. And this is how, well, I'm not going to go through the entire output because we don't have that much time, but you can see here that it's executing the intermediate Python code and that it triggers the next crew, that it's the interview question designer. So it crafts some kind of questions. It also provides questions in different levels, provide the answers, and yeah, it finally crafts some kind of coding task. So it can be like an initial entry point when you need to, for instance, prepare an interview or pre-screen some kind of CV. That's the demonstration of the flows feature in Crew.AI, and let's go back to the presentation. So yeah, as I mentioned, Crew.AI is not only a framework, but it's also a platform. So they have something called Crew.AI Enterprise, and they also have a command line interface. And you can create crews from scratch using the command Crew.AI create. It creates all the folder structure that you need in Python to create the crew, to implement the crew. You can replay tasks, so replay executions with the same input. You can get the logs, you can reset the memory, you can run the crew locally, and you can deploy your crew to the Crew.AI Enterprise. So this Crew.AI Enterprise is essentially a platform that abstracts you the deployment and resources management of what you need to run the crew. And the crew is just the piece of software that interacts with the LLMs. So you're not deploying any kind of model, you're just deploying that piece of software that handles memory, that handles the crew interaction, the agent's execution, stuff like that. But you need to provide the API keys and everything to the external LLM, or if you're running the LLM yeah, you have to tell the crew how to interact with your models. And essentially, when you deploy those models, it's like a wrapper, and it exposes some endpoints that you can use to interact with your agent. And these are the endpoints. So, for instance, if you want to know what are the input fields, you just need to call this endpoint. If you need to, that's the inputs. If you need to kick off a crew, you call the kickoff endpoint, and you can get the results by getting the status of the task. That's what we are gonna see in our third and last demo today. So to deploy the crews, you can do it in two ways. Using the command line or using let's say the console of Crew.AI Enterprise. If you're using the command line, you have to first create run the Crew.AI create, and it will create this folder structure, the config with the YAML files, some kind of let's say tools or basic classes to create your tools, the crew itself, and the main. It will be like the entry point to execute your crew. So once you you run that command, you get this folder structure, and then you need to sign up using the Crew.AI command line, and you run the Crew.AI deploy command, or you can use the command the console. Here you need to, of course, having some kind of repository of where you have all your code. You integrate that repository into this platform, and you just click deploy, and that's it. So here I'm deploying a simple crew that essentially takes a topic and makes some kind of research about that topic. It's very, very simple. And it's the default example they have to deploy. So once it takes more or less 15 minutes to deploy your agent, and it gives you an URL and a token, so you can access it via API. And that's what we have here. So I already deployed the researcher crew. When I call this endpoint, I get the inputs And the input is just the topic, just for the sake of simplicity. It's just a topic. So now I can kick off a crew execution, just sending this topic, and it returns a kickoff ID. Then I can get the status using this kickoff ID later. You can also send metadata in this object, and some kind of callbacks when this is done. So if you need to call some kind of webhook after the execution, you can do it by specifying here. Just for simplicity, I just take the kickoff ID and I can get the status. Of this execution, and yeah, here essentially I can see what's the result of the crew execution. So here we can see what's the last step in the crew execution to not overwhelm the output. But yeah, I think it returns only the result. And that's how you can execute and deploy crews in the cloud using their platform. Of course, you can also use other cloud providers, but in that way you would need to create the wrappers and the endpoints around your crew. I thought this was the simplest way to show it in action. And yeah, we can wrap up with some conclusions. Essentially, Crew.AI is a platform and framework that simplifies multi-agent collaboration. It abstracts the complexities of the agent creation. You can create agents to coordinate between them and tackle complex tasks by dividing them into subtasks and flows. You can also use regular Python code using the flows. You can also deploy those crews using the command line interface and the Crew.AI cloud that they have. They are still developing the cloud. So yeah, it may suffer some changes continuously, quite often. And yeah, a final note about the cost. So as you probably know, these agents runs in a loop, and that means that there are more requests to the LLMs. So it's crucial to monitor the applications to control the cost. It was out of the scope of the presentation, but you can use tools like LangFuse or Langsmith. There is also a telemetry API inside Crew.AI, and you can get the cost of the executions. But yeah, for simplicity, it can give us more topics for further talks. But it's important to note that you have to be very cautious about the cost and monitoring the cost. And yeah, that's pretty much what I wanted to present today. So I think, yeah, it's time for Q&A. Thank you for your time.
Yeah, I mean, like, truly a lot of details, truly very detailed presentation. So one from my side. So have you already successfully built like and tested one in the real business environment? Other like actually doing some tasks independently, you know?
Well, at this, I mean, so far, using this framework specifically, not in real projects. I mean, in like real business scenarios in which you need to maintain um, the crews or the agents running like continuously. But it's certainly, I think it's a good framework to outline in a very structured way how you can divide those tasks, how you can.
Okay, so unfortunately, still a bit on the theory side, not yet seen AI agents crawling around enterprise infrastructure, right? So we're still not there. I mean, the industry.
Yeah, it's evolving, and yeah, I mean, personally no, but I mean, personally no, I haven't used this to like an enterprise like application, but I know that it's being applied in a lot of use cases. So it's
Okay.
mhm.
Okay. Um, okay, and what about like syncing the agents? So have you thought about like creating maybe an army of those? You know, what could be used about their like joint work, or this is only a concept for an independent AI worker?
Sorry, what do you mean by?
I mean, like, have you been thinking about putting like 10 of those and
Mhm.
syncing them with each other? Uh, is there a way to sync them?
Yeah, yeah. When you specify the process, you can specify the way they interact, and you can make a sequential process, a hierarchical process. You can also say that the context of one agent is the output of the previous agent, stuff like that. So that's the way you can like sync them to accomplish a complex task.
Okay. There is also a question from the chat. Lesya Volovets is asking how to build, own, or use third-party agent together with Crew.AI team of agents. I think most of the presentation actually covers the answer to the question how to build your own agent, right? Because I
Mhm,
think David
mhm.
has been showing how to build third-party agent.
So
I don't know what was meant by that. Do you have a hint?
I mean, yeah, pretty much all the agents are custom because you
Okay.
have to provide a prompt to give them a goal and backstory, more context using the agent object, and you assign them a role that it's completely custom. So in that way,
Mm.
you can build any agent that
Yeah.
you can think of if you provide also the right tool. So by third party, probably it's about tools, maybe. For instance, if you need to
Probably.
interact with external or third party data sources or APIs, you can build your custom tools that actually have the contract of how you call APIs, how you interact with the database, or stuff like that, and you can equip your agent with that tool. So probably that's more like the question is referring to.
Okay, David. Actually, we need to choose a winner for LinkedIn Premium subscription.
Mhm.
I haven't seen any other questions in the chat, right? Except for one question from Lisa. So again, this means she will be winning the subscription.
Yeah.
If not someone posts another question, we give like 10 seconds. If not, so, we will conclude the session. But from my side, I think this was one of the most interesting sessions so far because it's so near the edge of what industry is doing. It's so near what businesses are thinking about. Because, like, from my personal experience, just like, yesterday, or the day before, I was discussing, with one of our clients about building an autonomous AI architect, for building construction. And I mean, the business perception is very often we are already there, right? Mm-hmm. But in reality, we need to do a lot of work, a lot of R&D, to substitute humans in various, roles. Okay, we don't have any other questions left. So Lesya, please reach out to the team. Oh, no, we have one. Oh, no. Did you say questions about? No, Them, I haven't seen the question above. Sorry. It was about data ingestion. Could you please post it once again in the chat? I don't know why I haven't seen it if you have posted it. Maybe that would be the most interesting question. If you hear us, please post it in the chat for sure. Yeah, we're waiting a bit. Yeah, sorry.
Yeah, just another note is like when designing these kind of agents, or for instance, in the case you were mentioning, it's like a good practice thinking as if you were building your own team. So building your own team, being the manager of your team, you can assign roles to specific members of the team. So it's like a very good mindset when you're developing this kind of crews.
Okay, let's wrap up then. So thanks a lot for your presentation. I think, David, that was really inspiring. Let's hope you'll be showing us in 1 year, in 2 years again on the Autumn Data Conference some progress on your work around Agent AI. So thanks for this session. And thank you all for joining the EPAM Autumn Data Conference 2024, and especially the Stream 2 Engineering Experience Unleashed, where we got deeper into the details of technical implementations of different data projects. From metadata-driven ingestion frameworks, scalable AI-powered business solutions, or multi-agent AI systems, benchmarking tools for biological data set. Each session, I believe, brought us really unique insights into cutting-edge technologies which currently shape our industry. As we wrap up, let's celebrate the incredible experience shared by the speakers. They're all like acting EPAMers with a great engineering experience, working with real clients, and are very dedicated to engineering excellence. And if you're seeking a place to innovate and thrive, EPAM is the right place to be. Thank you once again for making this event a success, and we look forward to seeing you at future conferences. And now, just in 10 minutes, in 3 minutes actually, switch to the mainstream of the conference, where Bogdan Hay, director from Data Practice of EPAM, Director of Data Analytics, will conclude the conference with his remarks. Farewell and have a good rest of the day.
You grow when you have a desire to become better, to learn new things. When you listen to a webinar, a conference, a talk, go to courses, dozens of courses, then you are the one who speaks. You grow. You grow when you get up to speed. When you focus on your work, on your customer, on your team, then you become a part of something big. When you raise the bar and take responsibility for your work, whether good or bad. When they ask you for advice. When you create a small revolution or speed up an evolution, then you grow. You are growing because growing matters to you. You keep at it until it's just right. To be honest with yourself and others, to further educate yourself, to become an expert. And if it matters to you, it matters to us. APAM. Focus on your growth.